High forces, and you times that by 2.
Does anyone by raise of hand want to look at a specific one? Team? What else? Please. 11. We may not do all of these, but 10. Cool. Here we go.
That's 2 for 9. We don't have a 304.
What'd you say?
I'm for 9 too, so if you don't do one,
Gotcha. 2 votes for 9. 3 votes for 9. I was gently coerced into doing number 9. All right. I'm very susceptible to that, so keep doing it. I hate, it's the busy work thing. I hate doing something that like the whole room's going, why are we doing this? But the whole room's like, oh yeah, I really want to know, then I love doing it. So, any questions to here? Well, in this factor, you really do have a hard time identifying poles and vertical asymptotes if you don't factor.
I was confused why there's a hole at 0 there.
Show you in a second.
I thought that X is over time was a hole at like 1.
Gotcha. No worries. No worries. That's okay to hear? David's question is going to show up in just a second. Awesome. Okay. The next thing I often do, I don't think I did this last time, but it helps a lot of people see what's going on. Once the expression is in factored form, you can break it up into lots of pieces. Makes it easier to see what's happening.
Recycling?
I don't. Thank you. So I want you to raise your hand. You don't have to show the whole world, but kind of at least show me if what I'm writing doesn't make sense. So all I've done is say, hey, if I multiply these things together, it becomes this. So they're the same thing. I've just broken them up into kind of categories, if you want. Like I noticed that there's an x factor in the numerator and a factor of x in the denominator. So I just put them together. Matching factors cause, well, matching factors, listen carefully to the word, matching factors can cause holes. So it's possible that this could cause a hole. Here's another set of matching factors that can also cause a hole. This factor is a sole factor in the denominator. A factor in the denominator can cause a vertical asymptote. So I've just split it up so it's easier to see. Questions to there? Awesome. We'll do this all year long, just breaking it up into factors. Please.
What would be an example of a factor that wouldn't cause matching factors that wouldn't cause?
Outstanding. Outstanding question. I'll say it about 8 more times in the next minute. Like really, it's solid, it's perfect. Here's an example. Let's say you had a different function Paris, and you ended up with factors like this. Okay, this will illustrate the idea. Okay, this factor of the numerator does match this factor of the denominator. The reason it doesn't cause a hole is because there isn't a value of x in the real number system, and we don't use the imaginary number system in this class. There are no real numbers that you can square and ever get a negative number. So there's no way to ever choose an x that will cause this to become 0 over 0, which would cause the whole. So even though they are matching factors, it won't cause a whole.
So if that was x squared minus 1, then it would be the whole.
Very good. So let's just write that one down. You're doing the perfect thing, Paris. Every time you can think of something that's related, it just makes your understanding more and more solid. It's perfect. This function actually has, here's a chance for everyone in the room to get the participation ticket today. This function actually has 2 holes, like at 2 different x coordinates. Just raise your hand if you know what are the x values of what's the x location of the 2 different holes? Because they're matching factors, so that can cause a hole. Your next thought is, okay, what's the value of x, which will result in this being 0 divided by 0? And there are actually 2 of them. There are 2 different values of x which can cause this to be 0 over 0. Follow me.
Negative 1 and 1.
Perfect. Positive 1 and negative 1. Either one of those x values will cause this to be 0 over 0. That makes sense, parents?
Yeah.
Other follow-up questions? Really good. Perfect. So we're back over here. So this answers David's question. Here's a set of matching factors. Full room again. We'll get everybody to get tickets today. Raise your hand if you can tell me what's the value of x which will cause this to become 0 divided by 0. Just raise your hand if you can see it. What's the value of x? Don't think too hard. If you're like, oh, then you've got it right. Okay. Thinking too hard, you're like, shouldn't be that easy. Like, no, it's that easy. Ethan, Lynn. 0. Now watch close. Everybody watch. Hey, the reason we write it out as factors is because I identified that the x value is 0. Well, that really means that all of these x's are 0. But 0 plus 1 is just 1. That's 1, that's 2. So I don't really care about any of that. Because once this is equal to 0, 0 times 1 is still 0. That's the whole value of listing them as factors. It makes it a lot easier to identify where the hole is located. Follow-up question. This function has a second hole. Raise your hand if you know where it is. Like the x location, I should say. Raise your hand if you can tell me the x coordinate of the other hole. Laura.
Negative 1.
Laura looks here and she says, hey, matching factors could cause a hole. When x equals negative 1, there it is. It's perfect. Question. And then there's a vertical asymptote as well at x equal negative 2 because of the individual factor in the denominator. Please, Priya.
So I can find out the whole vertical asymptote, but I just don't know why a number of 0 makes
Gotcha. That is a longer discussion. For now, don't know. What I mean by that is the question really is perfect. And if I had full control of your schedule, we would talk about it. But I don't. I have to send you off to the next class. So that one, don't stress too much right now. For now, if you can just remember that the number over 0 causes the vertical asymptote, it's good enough. We'll kind of keep going. It's a good one. Anybody else? Because it's not really a simple answer. Perfect. That was 9, right? Okay. Let's see. 7. 7 is already factored. But if I list the factors individually, it does make it easier to see what's happening. So please, as a class, just say yes or no. Are there any matching factors? No. It's kind of a bad question, to be honest. It actually was an unfair question.
Wait, no.
No, it wasn't. No, let me say it back to
You're
you.
saying if there's the same on the top and the bottom.
Yeah, I said it badly. No, it wasn't a bad
Oh,
question.
they're the same.
She is correct. No, Ken is correct. I said it badly. These are definitely matching factors. They're just matching factors in the numerator. And I should have said, yeah, is there a factor in the denominator that matches a factor in the numerator? I said it badly. I feel terrible. Okay. I'll be like doing, I'll probably send you an apology text and stuff. So, everybody good? Awesome. Because there are no matching factors, there's no holes. Okay? We just talked about what a zero is. Zero occurs whenever you get the actual output to be 0. If x equals 4, watch what happens. 4 minus 4 is 0. So this 0 divided by 1 is 0. So this is 0 times 0. It doesn't really matter what the rest is, as long as the bottom isn't 0. But the bottom would be 4. So there's definitely a 0 at x equal 4. That wasn't asked, but you will need that in the future. Questions? Please.
Wait, can you just repeat it?
So a 0 occurs at an x-coordinate, which causes the y-coordinate to equal 0. So when we've got 1, 2, 3, 4, 5 things being multiplied, somebody help her. If you have 5 things being multiplied, how many of those things need to equal 0 for the entire product to be 0? Just one of them. Yeah, you see that, right?
Yeah.
So if x equals 4, well, that puts a 4 here and here, but I don't care, because this is 0. If x equals 4,
Oh, I see it.
see it now?
Yeah.
Yeah, if x equals 4, this becomes 0. Say it again. No, say it louder. You had it.
Why is it 0? I just said 0 divided by 4 is 0. Or no? That's not what I meant to say.
Yeah, 0 divided by any number is 0.
Okay.
It's easy to get it mixed up. 0 divided by any number is 0. Yeah, that's easy to get switched. Got it? Yeah. Yeah, all the time. I get you. I get you. Just got to memorize that one. I don't have a trick for you or anything. Just divide by 0, undefined. 0 divided by number, that's 0. So this has a vertical asymptote at x equals 0. Have follow-up questions on that one? Oh, please.
Just by 0, that also means x intercept, right?
Oh, very good. So if you were trying to plot this, which they've never had a graphing question, but maybe someday they will,
Okay.
you would say that, this never have for years and years and years, over here at x equal 4, there's a point on the graph that's right there. It's perfect, because that's why this is a x coordinate of 4, y coordinates. Exactly what this going to be. Perfect. Please go. So I looked at these two and noticed that these factors are in the numerator, so they're not going to cause holes or vertical asymptotes. However, here I have a factor in the denominator, and it doesn't have a match in the numerator. And if x equals 0, I get what Ethan was saying. I get 1 divided by 0. Let's see, 0 times whatever's left would still be 0 on the bottom. The top won't be 0 because it's not a matching factor.
Oh, my goodness, not my hair.
Please, no worries. Anybody else? Oh, please, come.
So when you say 0 is at x equals 4, when you're trying to find that, you're just trying to like find what they're going to make the whole thing become 0.
Right, perfect. But if you separate, the key is separating them out as factors. Once you get everything separated, it really becomes pretty simple. Okay, I'll summarize it for you. Once the function can be listed as factors, factors that only occur in the numerator, okay, factors that are only in the numerator, as long as that factor can become 0 for some x, that will cause what's known as a 0. Okay, factors that only occur in the denominator, as long as there's a value of x, which can cause that factor to equal 0, that will cause a vertical asymptote. If you have as Ken noticed, if you have matching factors top and bottom, as long as there's a value of x which can cause both factors to equal 0, that causes a hole. Please. No, it could be over 12, 6, 8, 10. 0 divided by any number is 0. Perfect. Next one. 15. Okay. 15, this section of the piecewise is already factored, the denominator. I cannot factor the numerator, so no sense trying. So I just look at the denominator and say, okay, there's no matching factors since top doesn't factor. The denominator has a factor, x plus 3. There is a value of x, negative 3, which will cause the denominator to equal 0. That's a vertical asymptote. Your questions today are really good. Does anyone want to probe anything related to what I just said, or let me say it different or anything? Okay. Oh, please.
So just kind of like when I was doing it, the way I used that was if there was something at the bottom, so the limit of x to 4 minus or something like that. I've used those to plug in to piecewise function. If there's nothing at the bottom there, if there's no other number you can plug in to get, maybe a whole or another limit or something like that.
So what you're saying, let me say it back to you. What you're saying is you did a smart thing. You noticed that when I had associated limit questions, that kind of guided you as to where the hole was located or whatever. Is that what you're saying?
Yeah, I'm just trying to understand the concept of if those limit problems on the bottom aren't there,
Oh,
it's
gotcha.
possible to still get the other stuff.
Oh, sure. The limit problems at the bottom were just for you.
Okay.
They were just kind of like randomly, hey, here's some limit problems. Yeah, no worries. Good question. No, it really is a good question. You noticed a good pattern. So. Yeah, so they're not limited. Awesome. Jumps. So I looked at this formula and I rewrote it. The numerator has one factor. That's the only factor of the numerator. The denominator has two factors. As we just summarized, if you have a factor in the denominator that isn't in the numerator, that has the possibility of causing a vertical asymptote, as long as we discussed with Ferris a while back, you can find a value of x which will cause the denominator to equal 0. So you can test it real quick. Help me out, Ethan, real quick. So if x is equal to negative 3, what's negative 3 cubed? 3 times 3 times 3, so 3 times 3 is 9. You gotta get this one pretty fast. This happens all the time. 9 times 3 is 27. A negative times negative is negative. So negative 27 plus 9 would be negative 18. So this is negative 18. I don't care. All I'm looking for is 0. Oh, but negative 3 plus 3 is 0. So I'm going to get negative 18. This will become negative 18. This will become 0. That's what I want.
Okay, and why did you pick the top?
The bottom one can't have a vertical asymptote because it has no denominator that contains an x. Good question. Anybody else? Awesome. Let's check the whole room. So I want everyone to raise their hand if they know the answer to this. Looking at this piecewise function, it's possible that there is a jump. But this function has an infinitely long list of xy pairs. I don't want to check every single xy pair. So which xy pair should I check? 3 is one of them. What's the other one I should check? 3 plus. Because 3 is the last x in order that gets plugged into this formula. 3 plus is the first x in order that gets plugged into this formula. Follow-up question. So I do that. Let's see, 3 gets plugged into here. We've already done it kind of. 3 cubed is 27. 27 plus 9 is, thank you, 36. 3 plus 3 is 6. Squared is, thank you, so 1. Questions? 3 plus has to go here. So 2 times 3 is exactly 6. Minus 5 would be exactly 1. So this is really close to 1. Jump or no jump? No jump. These two are infinitesimally close, and these are also infinitesimally close. No jump. Question?
Wait, so there is a jump?
There is no jump in this case.
Okay.
This one only has the vertical asymptotes. Apologize, we got to skip to the level. We have time to come back. We got to start talking about the new stuff. Okay. Don't take any notes for a second. Like just look up. Like look at the board. Don't take any notes. This is when I want you to make real sense of the idea. Once you've made sense of the idea, you can kind of decide whether you feel like it's such a simple idea that you don't really need any notes, or it was like, I better write a couple of things down. Okay. So the assignment today is very short. It's only 8 problems. As I told you, once it made sense to Dallin Reichert, he finished it literally in like 7 minutes. So it's only 7 problems. It's the next, 8 problems. It's the next 8 problems in the packet. So it's 18 through, let's see, 25. Thank you, George. So it's 18 through 25. That's the assignment tonight. The assignment is about what's called continuity. Okay? Continuity means continuous. You want to know if the function is continuous. Understanding if a function is continuous is a really simple idea. Okay, we know that a function is a list, can be thought of as a list of x, y pairs. We also know that you can draw a picture of the function, we call that a graph, and all you're drawing are a bunch of dots. Every dot represents an x, y pair, and there's an infinite number of them. Or they can be, there doesn't have to be. So, if I kind of represent that, here's me creating a function. You know, just whatever, just kind of some random function. It's a bunch of dots. Okay, see if this makes sense. If you pick out any dot, and you notice that to the left and to the right, think of limits for a minute, like to the left and to the right, the 2 dots next door, so we're always talking about 3 dots. One in the middle, one on the left, one on the right. This is your left and your right, okay? If the one on the left and the one on the right are infinitesimally close to the one in the middle, the function is considered to be continuous at that point. Does that make sense? Okay? Now, here's some things that can happen that can cause discontinuities. You can have what we call a hole, or a removable discontinuity, and here's what happens. The function's just doing its thing, whatever, and then suddenly there isn't a point. It's just not there. That's a discontinuity because there isn't a point. And then the function continues. Like there's a missing point. We emphasize the fact that the point is missing by drawing an open circle. But an open circle is not a hole, okay? Like some people have that in their heads, just get it out of your head. The open circle is just a representation that nothing is there. We're okay on that. So that's a discontinuity as well, okay? It's just nothing's there, we're missing a point. Another way you can have a discontinuity is the function just does its thing, you know, points. Suddenly there isn't a point, it's somewhere else. Like it ends up there, okay? We won't figure out why this happens quite yet, just get the idea of like what we mean by discontinuity. So they emphasize that the point is missing by doing this, and then the points continue. They just do whatever, okay? That's a discontinuity. Question? Awesome. Here's another one. You can have the function going along just fine, and then suddenly the points are way down here. We call that a jump, okay? Or a jump discontinuity. Question? The last type is this. The function's going along, and then suddenly the y coordinates get like really, really high. they're heading towards infinity. And then suddenly at one point there isn't a point at all, and then the points kind of pick up again. Call that a vertical asymptote. Question? Okay, so those are discontinuities. And they all fit that same description of, I can't, like, look here. Any dot that I pick here, if I look to the left and the right, I find two adjacent dots. Fair? I can find all three. Here, I don't find the middle one. So that's discontinuous. Here, this dot doesn't have an adjacent dot on either side. That's a discontinuity. Here, same problem. Like, there's no dot right here. It's missing. Okay? They often will emphasize that on a vertical asymptote. They'll graph like so. They'll graph like this. And then they'll put a dashed line like this. The dashed line means the same thing as that open circle. There's nothing there. Okay? Questions? Awesome. Okay, so anything you need to put in your notes to remind you of that, go ahead and do that now. But for a lot of people, it's kind of straightforward enough, like, I think I can remember that. Questions? Oh, please.
So the first blue one, that means it's continuous and it's still going?
Right, so the idea is that any dot I pick, first of all, there's no missing dots.
Yeah.
Like this one just has a missing dot, so
Yeah.
that's a discontinuity. Second of all, any dot I pick, it has its two neighbors. That's like, this one is bad because this dot's there, but it doesn't have the neighbors. This one here, like if they graph this, you'll see them connect, look like the dots are connected because they're so close together. They'll put kind of a big circle there and a big open circle there. And this one has the problem that,
there's nothing there.
yeah, there's not a neighbor for it, so. Question. Okay, here's the technical definition of continuity. You do need to write this down and you do need to memorize it for future quizzes. Okay, the technical definition is, it matches what I've been saying, but here's how you write it mathematically. So look at this one. The problem here is what Kesta just noticed. There isn't a point. Okay? So for a function to be continuous, there first must be a y-coordinate. So like, let's just do an example here of the definition. So we'd say f of x is continuous at x equal a 7, just random example 7, okay? F of x is continuous at x equals 7 if the first thing you've got to have is the value of the function must exist. Like there has to be a point at 7, so you have to have an f of 7 value. That value's y-coordinates, the y-coordinate at 7, that's what this means, must be the same as, or you can think of it as infinitesimally close to, the value of the y-coordinate that's on the right. But we've talked about what that means. That means you're finding the limit as x approaches 7 from the right. Those two must be the same. That's what you see up here. So as Kesta was saying, if I pick a point right here, and this point happens to be at x equals 7, I can see that, yes, there is a point, so f of 7 has some value. The point to the right, say here, if I find the limit, it's going to be really, really close to 7. On this side, it's going to be really close to 7, so the limit, both left and right, will be equal to 7. That's the technical definition. So we need another equal sign over here. So it's left, middle, right. Question? Did you get that written down? If you remember that when we found the limit from the left, it really was just finding the y-coordinate of the point that is to the left. And when we found the limit to the right, it was just finding the y-coordinate of the point that is to the right. So all 3 points have y-coordinates that are infinitesimally close to each other function is continuous at that center point. Perfect. Almost just a second longer for me to catch up to their notes. Awesome. Okay, the 8 problems you worked tonight, they're dealing with functions that we want to ensure that the function is continuous. Okay, the first 4 problems are dealing with this situation right here. Wrong button. Hold on. They're dealing with this situation here, the jump. So the first 4 problems deal with this situation. They give you a piecewise function, and you have to design the piecewise function so that there isn't a jump. Like you have to choose constants A and B so that this doesn't occur. Okay, so read that. The second 4, they're dealing with this situation right here. The function has a hole. It has a missing point. But if the point is missing, the function isn't continuous. So you're going to fix the problem by creating a point that goes right there. So you create a point that lands right there, the function becomes continuous. You're basically moving this point down to that spot. So that's what you're doing in the second 4 questions. Let's look at them now. Let's look at the second 4 to start with. They're a little harder to kind of grasp. So looking at the second 4, the homework, number 24 is a good one. So looking at number 24, look at the structure of this function. It's really crucial that the structure makes sense to you. The structure makes sense, solving the problem is really very easy. They're telling me that this is how I find every single xy pair in the list. What this means right here, x can't equal -2. What that really means is that if you create a list of xy pairs for this function, every single xy pair except for 1 is computed using this formula. The only xy pair that isn't computed using this formula is when x equals -2. So saying that x can't equal -2 really means x can be anything except -2. Questions there? So we're going to use this formula to create every single xy pair. The top one. Because the instructions tell us to do so. What we're going to find though, let's factor this. So pull out a 10. Let's see, that'd be x squared minus 2x minus 8. Pull out a 5. That'd be x plus 2. Those divide to make 2. Factor the top again. Anyone have trouble with factoring? Let's catch up. Everybody okay? If we do like we did earlier today, if we split out the factoring a little bit, we get 2 over 1. Like that. Questions there? So what do you see? You see matching factors, numerator and denominator. That can cause a hole. This one does cause a hole at an x-coordinate of -2. That was all predicted by what you saw earlier. In fact, they're giving you a formula, and they're saying plug in any x you like, but if you try to plug in -2, you're not going to find a result. It's going to be undefined. So they're saying don't plug -2 in, it doesn't do any good. You just get undefined anyway. So we can come up with that. So what they do instead is they say, hey, when x is -2, since this formula won't give you a y coordinate, just you choose the y coordinate you'd like it to be. The a represents whatever number you want it to be, but we want the a to be the exact y coordinate necessary to plug the hole. So back to the picture, I'll just draw over here, so don't pay attention to this. So I don't know what this function looks like. It actually turns out to look something like this. There's a bunch of dots. They're going along just fine, and then suddenly there isn't one. And just say it out loud. What's the x coordinate where we're missing the dot? -2. Okay, to plug the hole, we simply need to put a dot right there. We already know the x coordinate, it's -2. We just need the y coordinate. Well, we can find the y coordinate by, somebody knows, like how can we find the y coordinate?
You just plug -2 into whatever does the rest of the equation that doesn't make it like a hole.
Nicely done. What he's essentially doing is saying, technically can't find this y coordinate, but I can find this one that's really, really close. It's the idea of a limit. I can find the point that's just next door. I can find the point that's next door here. The one in the middle's got to be in the middle. So he comes back to the formula and says, well, I'm trying to find this one. I'm plugging in a little more than 2, or -2. This will become 1. -2 minus 4 is -6. -6 times 2 is -12. So over here, when x is equal to exactly -2, this formula is definitely 0 over 0. But a little bit before, this is really close to -12. A little bit after, this is really close to -12. Okay, one more warning, I'll keep warning you all year long. Don't solve this problem by memorizing the process. It won't help you. The actual AP question that you will encounter will be worded differently. Now we probably need to see if you get the idea.
Why does the middle one equal 1?
The middle one equal 1. Oh, right here?
Yeah.
Oh, so anytime you have something divided by itself, that's equivalent to 1, unless you have 0 divided by 0. That's why I say when you plug in -2, it's not 1.
Okay, so then it's a little bit more.
A little bit more, we're okay. That makes sense? That's perfect. Please.
So I understood.
Good job, Dave. Say again.
How'd you get to it?
So I did what Ethan just did. I plugged in a little more than -2.
A little less.
Sorry, a little less, thank you. Which means this will now equal 1. Because if this isn't exactly -2, this will not be 0. Something divided by itself is equal to 1. So then I plug the -2 here, so -2 minus 4 would be -6. Just a little bit low, awkward close. Times 2 here would be -12. This was already 1, we're dividing by 1, so it's really close to -12.
Well, that makes sense, okay.
Plug it out. Perfect. So we figured out that this needs to be -12 to plug the hole. Questions? Okay, go to the other 4. So the page prior. Okay, notice the structure is different. This is a more typical piecewise function. We have one formula for a whole bunch of x values. You have a different formula for some other x values, different formula for some other x values. Okay, kind of a classic piecewise function. That means what you're worried about, there's no rational functions here. This one isn't rational because it's not divided by something with an x. So all we're worried about are jumps. So to prevent a jump, we just have to make sure that when we stop using one formula and start using the other, the y coordinates are infinitely close to each other. Questions? So what x coordinate should I first be concerned about here? 2, because that's the last x that this formula uses. So let's see. Plug in 2. 2 plus 1 is 3. 3 squared is 9. If I plug in 2 plus, that uses this formula. So let's see. 2 plus squared would be 4. So it's pretty close to 4 plus A, not exactly, but pretty close. Questions? I want to choose a value to take the place of A so that there isn't a jump.
You need to choose
5. A equals 5. A is 5. There won't be a jump when I stop using this formula, start using this one. You can tell when it makes sense. Like, you can feel the difference between making sense versus, like, I guess I'm just memorizing the steps, but I don't know why. It's the why that's important in this class. It's like overwhelmingly important. And it's going to be important in the college classes you take as well. So I'm trying to get you to shift your mindset from, honestly, like a lot of high school things where it's just memorizing to why does this fit together? So, questions here. What's the other X coordinate I should be concerned about? 4. So then you just do something similar there. So I'll let you finish it. I'm going to pay tickets. Good work. 8 problems for homework tonight.
So it says 18, just A equals 5.
A is equal to 5, then you have to figure out B. So
B?
the letter B.
Oh.
1 or 2?
It's B.
1 or 2?
Here, I have like 4 times 4 is 6.
Look at the other side.
No. So this one.
So now I'm here. And I need this to equal 26.
So one ticket is going to
Then I'm doing
You didn't
1
talk when
times
you're talking,
4
not on your cell phone. You go on to
plus 9.
the second point is
I can't find it.
B equals 3.
It says limit
Plus 9. What is X?
Yeah, one is like I didn't talk when I'm talking, and it wasn't on my cell phone. The other tickets, I participated. D equals 3.
Just one question. On this, how is it kind of like the last percent?
Yeah.
But we didn't find limit on
Oh yeah, there's lots of them. 1 or 2.
Would you do it on this one?
You can't do it on this one because finding a limit means the X value never equals.
Oh, next one.
Does that make sense?
Yeah.
Yeah. There you go. Stephen, 1 or 2.
What the heck? Why was I saying that?
Yeah, we did.
Oh my god.
For some reason, I was thinking of doing it like
I love it.
How are you?
Good, so good to see you.
You too.